Welcome to my channel. So in this video I am going to explain the 8-bit subtraction using 8085 microprocessor. So before going to design the programming, let us see the manual concept of subtraction. So here the subtraction indicates what? A minus B. So here add money and subtract. So A indicates money and subtract. So it consists of two sections. Okay, so this subtraction can be analyzed in two cases. That is case number one. So case number one. In case number one, if A is greater than B, if A is greater than B, there is no borrow over here. Okay, so borrow is what? So borrow. So borrow is equal to 0 only. So there is no borrow is generated. So automatically you can perform the operation. Now case number two. So here case number two. In case number two, if A is less than B, if A is less than B, so you will get what? Borrow. So borrow is equal to 1. And also in binary subtraction, you won't get correct output, right? So I want to explain, okay, how the case 1 and case 2 will be operated. For example, if 0 7 and 0 3, if you subtract these two, if you subtract these two, what you'll get? 0 0 0 0, and 7 is what? 0 0 0 1 1 1, right? So this is the binary representation for 0 7. Similarly for 0 3, 0 0 0 0 and 0 0 1 1. So if you subtract these two, so 1 minus 1 0, 1 minus 1 0, 1 minus 1 minus 0 1 0, then 0 0 0 0, right? So here 0 and 4, you will get the exact operation in case of what? A is greater than B. If it is A less than B, for example, if A less than B means, so I am going to assume the operation. So for example, A less than B. So what is the operation? Assume. So A is equal to 0 3. So if 0 3 indicates 0 0 0 0 and 0 0 1 1, right? And for example, if B is equal to 0 5. So if 0 5 indicates what? So 0 0 0 0 0 1 0 1, right? Now if you subtract these two, what you will get? So 1 minus 1 is what? 1 minus 1 0, and 1 minus 0 1. 0 minus 1 is what? So 0 minus 1 is not possible, so you have to take the borrow over here. Now I am going to take the borrow over here. So if you take borrow as 1 means, so here you will get what? 10 1 0. So 1 0. So again I am going to take the borrow. So here 1. So in 1 0, in 1 0, that is 1 plus 1 is equal to what? 1 0. So in 1 0 you are having two ones, right? So here if you take borrow, here 10 is there, that is 1 0 is there. In 1 0 contains what? So I want to take another borrow here. So 1 is remaining and here 10. So again 1 is remaining, here 10. So again 1 is remaining, here 1 0. Again 1 is remaining, here 1 0. Again 1 is remaining, and here 1 0. So 1 0 contains how many ones? Two ones. So in that two ones, if 1 is subtracted means you will get 1, right? And what is the subtraction? 1 minus 0 1. Then here 1 1 1 1 and borrow is 1, right? Now so this is what you will get. What is the answer here? 0, here 0 2, that is minus 0 2, right? So this is not true result. Actually this is not true result. Okay, true binary form result 0 2. So in order to get the true result, you have to, so one concept is that there is representation of negative numbers. Representation of negative numbers can be done by using 2's complement notation. So you just take 1's complement for this one. So if you take 1's complement for this one, what you will get? 0 0, that is 1 as 0 0 0 0 0 0 0 0 1, and 2's complement. If you take 2's complement for this one, adding 1, so what you will get? 1 plus 1 0 and carry over 1, so 1, so 0 0 0 0 0 0. This is what? 0 2. This is the true result for 0 3 minus 0 5. This is in case of what? Case 2, right? So here if A less than B means you have to perform the complement operation. So you have to keep all these points in your mind. Okay, so if A is greater than B, no problem, there is no problem over here. If A is less than B, you have to take them for the resulting operation, you have to take the 2's complement for getting the true result. Okay, so this is the concept behind in subtraction. Now we have analyzed all the manual concept. Now I am going to transfer the this manual concept into programming concept, right? Now the same operation, now I'm going to initialize move, sorry, so mvi c comma 00 for storing borrow. Okay, mvi c comma 00, h indicates here hexadecimal value. So here move immediate data, that is 00 is the immediate data that is loaded into C register for storing carry. Initialize the C as 00 for storing carry. Now I'm going to take the first data, that is minimum data. So minimum data means I'm going to take the first data, that is LDA 4100. Okay, 4100 is what? Memory location. Okay, now 4100 is what memory location means. So I'm going to assume the memory location over here. Now I'm going to assume the memory location. So this is the memory slot. Just assume the memory. So these are the memory. Okay, so 4100. Now I'm going to take the first data, for example 07, right? So now LDA 41. So whatever the content which is present in 4100, that is loaded into accumulator. So first data is over. Next you need what? Subtrahend data. So in order to get the subtrahend data, first you have to move the accumulator content into some other register to get the another data from the memory, right? So for that purpose I'm going to use a move b comma a. Okay, so move b comma a indicates, so I'm going to move the content of a to b register. Okay, that is move. Okay, next I'm going to take the second data, that is 4101. So for example this is 3 is there, so here LDA 4101. Okay, so LDA 4100 means whatever the content which is present in 4101, that is loaded into accumulator. Now one data is available at B register and another data is available at A register. Okay, so here now the two operands is over, that is A operand is over and B operand is over. We have to do the processing operation. Okay, what I told here, so first operand, second operand. So after getting two operands, perform the operation. What is the operation here? Subtraction. So after subtraction is over, so here processing is over, you have to check whether the difference and borrow. Okay, so that is borrow is generated and difference. Okay, you have to store the result. Okay, this is the concept, right? Now two operands are I have taken from the memory, right? Now I am going to perform the operation, that is processing, that is sub b. So sub b indicates what? So A, that is A is subtracted with B register. A is subtracted with B register. So now let us assume here. Okay, for example here C is equal to 00. So now I'm going to tell the internal operation. So at this point what you will get? 4100 contains what? The 41001 contains 07. So A contains 07. At this point A contains 07 and also B contains 07. Right? At this point 4101 contains what data? 03. So A is equal to 03. Right? Now if you do the operation, what will happen? So now at this point 03 is what? 03 minus 0. B contains what? 07. So 03 minus 07 indicates what? 03 minus 07 is actually 04. Okay, that is borrow. So that is minus 04 means borrow. Okay. So here that is 03 is what? 03 minus 07 means B is greater. That is case number 2. So if case number 2 means that is borrow is generated. So the result you are going to get what? You are not going to get the true result. So for that purpose, what you have to do? You have to perform the two's complement operation, right? So sub B is over. If jump no carry, now you write first check the operation. Jump no carry, write loop here. Okay. If jump no carry means what? If in the case 1 you are having what? A greater than B. In case 1 you won't get any borrow concept. If jump no carry, that is borrow carry here, borrow carry and both are same here. Jump no carry means if borrow is not generated, go to loop. Okay. In case at this point borrow is generated. Okay, so what you have to do? You have to for borrow, for storing carry, that is borrow, for storing borrow here C is initialized, right? So INRC I am going to increment by 01. Okay, in case of addition just C take it as carry. In case of subtraction C take it as borrow. Okay, so INRC. So after INRC, here the accumulator content is what? 04. This is not true form. Okay, true form you won't get in binary form, binary result, right? So what you have to do? You have to perform the two's complement operation. For that purpose, I am going to use here complement accumulator, CMA. This CMA indicates complement accumulator. So Two's complement means what? Again, you have to use here INR A, INRA indicates after complement operation is over, INRA indicates incremented by 1. That is 2's complement. So at this point, 1's complement. At this point, 1's complement. At this point, 2's complement you will get. So here the true result is available at accumulator. Now you just store the result. So STA4300. So here for example, here so many memory locations are there. Here 4300 and 4301. So any memory location you can use, or otherwise you can use the next term memory location also 4102, right? So here 4300 means here jump whatever the content which is present in accumulator, that is loaded into 4300. This is in case of what? Case number 2. These three instructions will be executed in case of what? Case number 2. For case 2, it is going to execute, right? If case 1, okay, that is case 2 is not applicable, directly jump no carry to loop. Jump no carry loop indicates directly it is going to store the result. This loop condition will come here. Okay, so directly store the result to accumulator content into 4300. So you will get here 04. Okay, now so the difference result is stored. So you have to store the borrow result. So where is the borrow result initialized? That is C register. So just move A comma C, right? Move A comma C indicates so whatever the content which is present in C, that is moved to accumulator. Then STA4301. So here 4301 contains what? 01 you will get. Okay, so then halt. Okay, halt the operation. Okay, so this is the basic program for doing 8-bit subtraction. Okay, you have to remember. Okay, first you just analyze the concept. Okay, by using that concept, transfer that manual concept into programming concept. So this is the basic way to design any type of program. Okay, so this program indicates you can perform any type of whether if A is greater than B or A less than B. So this program will satisfy for both conditions. Okay. So hope you understood and enjoyed this video. So if you please subscribe, like and share this video. Thank you. Thank you.